So today, or for this video I should say, the topic is writing numbers in scientific notation. And so this is your I can statement for your notes. And this is an 8th grade lesson from lesson 2, video A. There's going to be 2 videos for this. Okay, so let's get right to it here. What does it mean to write numbers in scientific notation? Well, scientific notation is a way to write really big numbers in a small way and really small numbers in a big way. It also helps us see information about a number, I guess you could say, easier than not. So for example, if I had 63,400,000, that's a pretty big number. And all scientific notation is turning a number into a multiplication problem. So the first step when you want to write a number that's in standard form, by the way, we call this standard form. You might want to write that as your vocabulary, standard form, the regular way you write numbers. So the first step is to move the decimal point until you have a number between 1 and 10. Sorry, that's sloppy. My pen kind of quit working there for a second. And so I'm going to go to the next slide. So 63,400,000. If that first step is to be played out, you have to know where the decimal point starts. Well, it starts here. And it said I want to move that decimal point until I have a number between 1 and 10. So I'm going to move it 1, 2, 3, 4, 5, 6, 7 places. Because now I have 6.34, okay? But remember, whenever we are writing numbers in a different way, okay, we want to go from standard form into scientific notation, we don't want to change the value of the number. And the announcements are going on right now, but hopefully those won't bug you too bad. So 6 34 is more than 1, but it's less than 10. So this right here does not equal 63,400,000. It just doesn't. So we can't just say that 63,400,000 equals 6.34 because it doesn't. We have to multiply this 6.34 by something to make it mean the same thing as what we've got over here. And the way to do that is to decide how many places did I have to move the decimal point. Well, I moved it 7 times. Okay? So that means then that this number right here, 63,400,000, would equal 6.34 times 10 to the 7th power. And this is why 10 to the 7th power means 5, 6, 7. It's this really big number that means 10 million. So you're multiplying 6 34 by 10 million. And when you multiply a number by a power of 10, the decimal point moves to the right as the number gets bigger. So if you were to play this multiplication out, if you were to actually sit down and do all the multiplication, it would equal what you started with. So first step is move the decimal point until you have a number between 1 and 10. Second step is multiply that by a power of 10 that matches the amount of movements the decimal point made.
Every time I feel bad about myself, she reminds me about the good things. So thank you, Claudia. And happy birthday.
In other words, if I had to move my decimal point 7 times to get this number to be 6.34, then I must have to multiply that by 10 to the 7th power to turn this number back into this number. So all I'm doing is I'm converting numbers that are in standard form into scientific notation. I'm going to do one more example with you, and then this video is done. What about really small numbers? Okay, like tenths, hundreds, thousands, 10,000s, millions, 10 millions. This is 45 10 millions. It's a super small number. Well, the steps stay the same. First, move the decimal point until you have a number between 1 and 10. So in this case, I'm going to move it 1, 2, 3, 4, 5 times so that I have 4.5. So then you would think if we do this the same way that we did the other one, multiply that by a power of 10 that matches the amount of movements the decimal point made, then we would multiply it by 10 to the 5th because we moved the decimal point 5 times. But here's a crucial difference. 10 to the 5th is actually 100,000. And if you multiply 4.5 times 100,000, it does not equal 45, whatever this was, tens, hundreds, thousands, 10,000s, millions, 10 millions. Doesn't equal 45, 10 millions. So what must we do? Well, let's think about it like this. 4.5 times 10. I know my exponent should be 5 because I moved my decimal point 5 times, but I know I need this number to become smaller than 4.5 because I need it to match this number, which is a really, really small number. Oh, the exponent must be negative. Because remember, 10 to the negative 5th means 1 over 100,000. And if you were to multiply 4.5 by this, you would get 4.5 divided by 100,000. And what would happen to the decimal point if you actually did this math, you plugged it into the calculator, the decimal point on the 4.5 would move to the left 5 places. 1, 2, 3, 4, 5. And we would start where we would get the number that we started with. So what does that mean? That means if you take a really small number, like the number we had here, and you want to turn that into scientific notation, follow the first step by moving the decimal point until you have a number between 1 and 10. But then you have to keep in mind, which way did I move the decimal point? Did I make my number bigger? If I made the number bigger, if this is bigger than this number, then I have to multiply that by something that will make it smaller again. If, however, I made my number smaller, I went from 63,400,000 to 6.34, then I have to multiply it by a power of 10 that will make this smaller number match this number over here, this larger number. So, this is the final answer to this second example problem. And so when you try this, you're going to be given numbers like this. And they're going to ask you to turn that into scientific notation. First, determine how many times do I have to move my decimal point to get a number between 1 and 10. And write that number between 1 and 10. Oh, I had to move it 1, 2, 3, 4 places. Okay. So I know the exponent's got to be 4, but now should it be a positive exponent or a negative exponent? Well, this number right here is a lot smaller than this number. So I need to make this number bigger to match this number. Therefore, my exponent should stay positive. But in a number like this, if I was going to write that as scientific notation, I would first write it as a number between 1 and 10, and then I have to figure out how many times did I move my decimal point to get it to 2.7. 1, 2, 3, 4. So times 10 to the 4th. But this number here is a lot larger than this number here. And I want this, everything over here to equal this number. So I must have to multiply it by some really small number. So a negative exponent to make it match. Anyways, good luck to you. Bye.